Welcome to my Action Research multimedia presentation. What we want to do is look at some of the core elements of my research project, including the refined and focused research question, some of the definitions that I used throughout, the literature that I consulted that informed the orientation of my research project, the data that I will use to substantiate my claims, and finally some of the reasons why I think this project is especially important and relevant for educators today. My problem statement was informed by two core values that I want to talk about briefly. The first concerns differentiated learning, and the second includes the development of an inclusive classroom. In terms of differentiated learning, what we simply mean is that each student possesses different academic requirements that need to be attended to. And so it's our responsibility as educators to recognize those differences in terms of their learning strategies and their learning requirements, and then develop lessons that meet those particular requirements. And the second is concerns the inclusive classrooms that we want to build. And that fundamentally means that every student in the classroom should have the opportunity to learn, regardless of limitation or differentiation. The problem that I'm interested in exploring concerns the use of math manipulatives in our math instruction. And the problem that I noticed was how to select effective tools for successful instruction. In my own placements, I recognized that students were not selecting appropriate math manipulatives, or they're selecting manipulatives that were distractive or that directed them away from the assigned task rather than actually equip them properly to develop content knowledge about a particular math concept. And so their poor selection and even sometimes the availability of the resources that would have helped them really helped direct and shape my question. But also, the kind of literature that is present today really informed my interest in this problem. There's a lot of academic research which is supportive of the use of math manipulatives in the classroom. There's also literature available as well, which highlights the drawbacks of math manipulatives and raises some very, very good questions that we need to explore as educators in a context now that is really, really pushing for the inclusion of math manipulatives in math instruction. My research question then focuses on my grade 2 students. And the question that I crafted concerns the improvement of my ability to select and effectively utilize math manipulatives for my math lessons. So how can I do this? So it's important to go over what we actually mean by a math manipulative. Even though we use the term very often in our classes, we may not know what it consists of. So a math manipulative is an object that is designed to enable a student to perceive or grasp a mathematical concept. It's an object that affords students the opportunity to develop and explore math concepts through appropriately leveled hands-on experience. So there's two important elements I want to highlight in this definition. Math manipulative is not meant to simply engage or create a fun atmosphere for students. It's meant to be a tool to help them perceive or grasp a mathematical concept. So that's its objective, its primary objective. It doesn't mean that it can't have fun, and it doesn't mean it won't be engaging, but again, its primary objective is to be a tool to help them grasp a mathematical concept. It's also an object that needs to be appropriately leveled. So again, going back to my core values, a math manipulative shouldn't just be uncritically handed out to your students. It needs to be considered. And this consideration should include who is in your classroom, what are the particular academic requirements, and if this tool is suitable for that student in a way that would enable them to grasp an idea, rather than act as a detriment or barrier. So the notion of leveled and hands-on experience is important here. In terms of the literature that I consulted, academic studies have demonstrated that the use of math manipulatives as pedagogical tools designed to facilitate student comprehension and translate abstract concepts into mathematical forms are often unsuccessful because teachers are not sufficiently equipped to utilize this instructional strategy. While teachers have highlighted the benefits of allowing their students to engage in fun, manipulative-based math activities, the mere presence of math manipulatives does not guarantee that students are learning the material. Effective manipulative-based math instruction then requires a critical examination of how these tools are being utilized, along with the development of content knowledge that informs the effective use of these teaching strategies. So it's not about simply having the resources available in the classroom, but it's how we use them that really counts. Simply having math manipulatives or incorporating them into a lesson is no guarantee that students will actually successfully develop math knowledge. In fact, it might even be a detriment in some instances. So it's important to recognize that having math manipulatives available does not, again, guarantee that students are going to develop that content knowledge successfully in the way that we want. While current pedagogical strategies have favored the implementation of manipulatives, there are important concerns being raised regarding the types of manipulatives that are being used and how they are being introduced into the class. The translation of abstract concepts into manipulatives has allowed students to explore and investigate math concepts that they would not otherwise grasp as successfully. This process, however, demands a degree of teaching confidence that is based on a working knowledge of content material. That is, the effective use of manipulatives depends, in part, on a teacher who is confident in their implementation of this teaching strategy and the underlying mathematical concepts. Teachers must critically engage how they use different manipulatives and what kinds of manipulatives they choose to introduce to their students. Whether you're a new teacher or whether you have been teaching for 20 years, the effective use of manipulatives depends on your working knowledge of how they relate to the particular mathematical strand you're teaching and even the lesson that you're working on that particular day. If a teacher has no idea how the math tool actually relates to the content of the lesson they're teaching, then it's not going to be effective. And that applies to teachers across the board. So these articles are highlighting the notion that what we're looking for, again, is that content knowledge and the kind of pedagogical sensibility that allows a teacher to successfully incorporate math manipulatives when they're needed and when they apply to a particular lesson. Integrating manipulatives into math lessons provides students with the opportunity to engage challenging concepts in ways that are suitable to them. However, this must be a guided approach that takes seriously occasions when these tools are hindering mathematical development rather than supporting it. While they are an important and valuable part of math instruction, teachers must be aware of how manipulatives are being used by their students, if they are appropriately connected to the concept they are trying to teach, and when the manipulative no longer functions as a helpful tool for the student. So in terms of the limitations of the research that I looked at, perhaps the biggest area concerns the data groups that were used and the differentiation in technologies that were looked at. And what I mean by that is there could be more representation from primary and specifically the grade 1 to 3 classes. There wasn't a lot of research available which looked specifically at younger grades and the use of manipulatives in those contexts. And they also didn't look very heavily at the different technologies that were available, including the digital technologies that might stand in the place of math manipulatives as tools to help students grasp concepts. So again, I would look at the different learning contexts, specifically the grade 1s to 3 grades, and also the different technologies that are available and how those are being used in the classrooms, either successfully or unsuccessfully. I will be collecting data from 3 different sources throughout my project. The first consists of pre- and post-task-based interviews with 3 selected students who are working at a high, medium, and low level of comprehension, respectively. The interviews will focus on 8 collaboratively planned manipulative-based mathematical problems and tasks. The interviews will be recorded using notes and anecdotal reflections. I use this because the periodic collection of data via task-based interviews will enable the educator to track results over a specific period of time, and this will provide authentic comparative data that will incorporate findings from different math strands and units, thereby demonstrating how students utilize math manipulatives throughout the course of the mathematics scope and sequence calendar. The second source will be student work samples and artifacts collected from lessons utilizing math manipulatives. These samples will be analyzed on an ongoing basis and will inform the direction of planning for subsequent lessons. The reason is because the data collected from student work samples and artifacts will be assessed to see which manipulatives students are using for particular tasks, how successfully they are using these manipulatives to perform these tasks, and whether students are learning to select different manipulatives for different tasks based on their efficacy and usefulness over time. And finally, I'll be using teacher journals. The reason is because the continuous journal reflection provides the educator with a written transcription of what has taken place, as well as providing the opportunity to critically articulate the reflections throughout the process. Each journal entry will focus on an appropriate prompt that directs the line of reflection back towards the central research question. In terms of validity, the data collection methodology is premised on utilizing data sources that are directly related to the central research question. This means that the task-based interviews, student work samples, and teacher journal entries will be formatted to include questions, tasks, and reflections that are commensurate and oriented towards the research question only. By crafting, conducting, and collecting data in this way, it will ensure that the information gathered and used will not deviate from the stated and intended objective of analyzing ways to improve the selection and use of math manipulatives. In terms of reliability, each of the data sources will utilize consistent structures, guidelines, and formats to ensure that the data collected does not change depending on context or time period. This means that task-based interviews will follow the same procedure for each interview. The student work samples will be evaluated using the same assessment tools and strategies, and the teacher journal will use the same prompts to guide critical reflection. Essentially, the organization and administration of data collection could be completed by anyone at any point in time. The data will be collected in the following contexts using the following participants. Who is involved? My students and myself. From the students, I will be collecting their work and also their task-based interviews. For myself, I will be using my teacher journal to reflect critically on the data I've gathered. Where will this take place? In the classroom, in the LRT resource room, and in the learning commons. The student work will be collected from activities completed in the classroom, where task-based interviews may be completed in the LRT resource room or the learning commons because we might need a quiet environment to complete these interviews. In terms of ethical considerations, each of the data sources utilized throughout the action research journey will not use given names or refer to any proper identification of any kind. Students participating in the task-based interviews will be designated with a letter, and student work will be identified and referred to in the same way. Similarly, the teacher journal entries will omit proper names and student identification to ensure total confidentiality and student anonymity. Students participating in task-based interviews will be asked for their consent prior to the administration of the interview, and a letter outlining the objectives of the research study will be sent home to their parents or guardians. Here is a timeline chart outlining the data collection process. For student work samples, they will be collected monthly, once a week, from September to April. For the task-based interviews, they will be conducted from September to April at the end of each month. And for the teacher journal, an entry will be provided from October to April once a week. The nature of this action research study focuses directly on both the Ministry of Education's mandate to support the math curriculum across the province and the District School Board of Niagara's policy to provide learning opportunities for each and every student. Because math instruction is continuously being reshaped and restructured to promote and reflect the differentiated learning styles of our students, it is paramount that teachers actively participate in this process through critical reflection and the cultivation of creative lesson plans that work to develop inclusive learning environments and experiences. Inquiry-based math instruction utilizes different math manipulatives as a primary means of connecting and introducing students to different math concepts. The selection of these manipulatives directly affects the ways in which students appropriate and construct knowledge as they explore these new mathematical ideas. It is therefore essential that the selection of math manipulatives be based on authentic and meaningful research that corroborates their inclusion and promotion. This action research study will generate important data that will contribute to the successful crafting and implementation of math lessons that effectively utilize math manipulatives.